Okay, up to now we've been talking about rational expressions. We first started with simplifying rational expressions, and we learned by simplifying what that meant was ignore the denominator for a second, just try to factor the numerator. Get that completely factored. The first thing you always try is greatest common factor, factoring out the greatest common factor. If that's not possible, then you try whatever else, whether it's, factoring a quadratic or whether it's whatever, you try it. Then you ignore the numerator and you go down to the denominator and you try to factor the denominator. And once everything is factored, upstairs and downstairs, then suddenly you have things multiplied times each other, right? And so if you have common multiples or common factors, right, that upstairs and downstairs, you can cross them out. So fist to 5, I think people are feeling pretty comfortable with that now. Am I right? Fist to 5? Okay. All right, good. There will be a repeat test for my group, for the regular group at some point on the rational expressions. I don't know, I'm going to wait for a little while. I think the longer we wait, the more comfortable you guys are going to feel with it. Because you use these same skills for all the stuff we're doing, right? Then we moved on to multiplying and dividing. And we found, it was the same thing. We simplify the numerator, we factor it out any way we can. We factor out this numerator, we factor out this denominator, we factor this denominator, and then anything upstairs or downstairs, right? Right? Anything, anywhere. Anything upstairs on either of those two, similar to anything downstairs, can be crossed out. So that was pretty easy, right? You guys get that? Fist to 5 on that. Awesome. Okay, good. All right, so now we're going to talk about adding and subtracting rational expressions. Of all of them, this is the hardest, okay? But because you have that other stuff down, this is really not that hard. It's going to be pretty easy. So first of all, let's just remember fractions, okay? Because you have to know fractions. You have to know how to add fractions just with numbers first. You have to just remember that. And I know everybody does, but my guess is some people are really rusty. So we're just going to do a couple here. Just to get our, so let's say we did 1/2 plus 4/6. All right, and we want to add that. Now, what do you have to have in order to add two fractions together, Juliana?
The 2 has, you have to multiply the 2 times the 3.
Right, so you're saying that you have to have a common denominator, right?
Yeah.
The denominators have to be identical. They cannot be different. I cannot add this unless I change this, right? It's impossible to add this without changing this. Well, it's not impossible. You could do it in different ways, right?
Well, actually, it kind of is, because you know that 1/2 of 6 is 3, so you just add 3 to 4.
You
So
could
then it'd
take
be 7/6, and so 1/6.
Right. You could take half of a donut and you could take 4/6 of a donut, and then you could smush them together, and then you would have the addition of them, right? But that's in real things. But as numbers, right, as fractions themselves, yeah, you've got to do something. And the key is that you're always going to multiply at least one of the equations by 1. But it's going to be a weird looking one, right? It's going to be like 2/2, or 3/3, or 5/5, or x plus 2 over x plus 2, right? You agree with me that those all equal 1? Same thing upstairs, same thing downstairs, it's 1, right? That's the way the 1's going to look. So the first thing you do is you ask, can I turn the smaller number into the bigger number in the denominator?
Didn't we do this already?
Yes.
Yes.
I'm only doing this, it's just because it's the preface of something much harder. And if you have this down, like if you're bored because you say, oh, this is so easy, perfect. That's what I want you to be, right? Because then you're going to have no trouble with the rational expressions, right?
No, I'm saying, didn't we add and subtract rational expressions already?
Oh, I don't know, did we?
No.
There's a chance I might have shown it briefly, but not to the degree you're going to do it now, okay? Yeah. So everybody probably would agree with me. 2 times 3 would equal 6, right?
Yeah.
So immediately I'm going to just do 3/3. That is the value of 1. I'm not changing the value of this fraction. I'm merely changing the way it looks. So multiply 3 times 1, it's 3. 3 times 2 is 6, plus 4/6. Now I have common denominators. My answer keeps the common denominator, right? And then it's 3 plus 4 is 7. So my answer is 7/6. I could turn it into a mixed number if I wanted to, but I don't want to. So I don't have to. So, and then if I had let's see here, what are we going to do now? What if I had 1/3 plus 2/4? Okay, suddenly I asked, can I turn my littler one into my bigger one? No. So now I look at my bigger one, right? And I multiply it times 2. So 4 times 2 is 8. Does 3 go into 8? No. So I take my bigger one and multiply it times 3. 3 times 4 is 12. Does 3 go into 12?
Yes.
Okay, so 3 times 4, right? So I'm going to do this, multiply this equation by 4 and this equation by 3, right? Because I want my common denominator to be 12. So now I have 4 over 12 plus 6 over 12, and that gives me 10 over 12,
Which is 5 over 6.
which is, thank you, 5 over 6. Because I can simplify, right? So fist to 5, you guys remember all this? It's pretty straightforward. I think you guys know it. Awesome. So that was just to get us warmed up. Because it starts to look, it's not that much more different or much more difficult with rational expressions, but people's brains short circuit when we start doing the rational expressions. And one of the things that I think people most often struggle with is finding the common denominator.
Common denominator.
Once you find the common denominator, it's a piece of cake. And it's not that hard to find it.
And then once you've added them, do you simplify?
Yes, yeah. You have to, yeah, and we'll get there. We'll get there. So the first thing I want to do is example 1, something very simple. So I'm just going to use the examples from the book because it's just easier. So example 1, 5 over 3x plus 7 over 3x. Okay. Do I have common denominators?
Yes, you
Yes.
Oh, I do. So I can just immediately put my fraction over here with my common denominator in the answer, and then 5 plus 7 is 12, right? So am I done?
No, because we can
simplify it.
Say it again?
You can simplify it.
You can simplify it. 3 goes into both of these, right? So I can say 3 goes into this once, 3 goes into that 4 times. So I have 4 over x, right? So that's my answer. So this big mess is all that really is just 4 over x. Okay? That's pretty easy, right? It's
Yes.
great when they're already common denominators, right? Okay, so now, before we actually do one without a common denominator, let's just practice finding common denominators. Okay?
So there going to be
number
any
two.
of those on the homework?
There will be lots of these.
No, like the ones where you have to find where the common where it's not a common denominator, and they're
That's what he's showing us. to do.
Yeah, most of what you're going to get for homework is going to be, you know,
Are you giving it out of the book?
I'm going to give it out of the book, yeah.
I don't have my textbook.
Because I want you to have, what?
I think.
You have your textbook at home, right?
Yes.
Yeah, let's
I
put that.
don't know what mine is.
Uh-oh.
I think I just left
My
it at
textbook
home and was
Okay,
missing
it's
it.
it's at home, you told me.
And then
Because you
I
couldn't-
I just
It was
misplaced
too heavy, right?
Yeah, I misplaced it, but it's so big.
Gary, mine was
You'll
backwards
find
on my bookshelf. It's
Yeah.
the only thing that was showing was white, and I couldn't
Okay,
find it for a
so
while.
yeah, and the nice thing about using the book is because you have all the examples right there, right? So like if you're confused, a lot of times when you're looking at the problem, you know, it says, oh, well, these are like example 1. There's
Right,
a
and you
whole
can
section.
also like look at the red in the back if you really like. If there's one circle in red, if you're really lost,
Right.
you can go and look.
Right.
See how you.
So there's a lot of advantages to the book, right? You just got to get used to it, and believe me, the book is going to save your life in as you move on, because there's going to be so many times when a teacher, you know, either goes way too fast, or talks way too slow, or too softly, or Betsy had a teacher in a math teacher in college who was just learning English.
Oh.
And I think he was either Japanese or Chinese, and she could not understand a word he said. And if she didn't have the book, she would have been lost, right? And then Jamie has a teacher right now who doesn't talk. She just writes problems on the board, quickly solves them, and we're talking about sines and cosines and cotangents and cosecants and things that you know you need somebody to explain a little bit.
Can she
And
not?
and she
Does he like
doesn't. Oh,
calculus?
she can talk. She just doesn't. Right?
She'll talk. She just
So
doesn't.
so a textbook is really useful, right? It's really useful to have that, you know, as a
Gary?
backup. Yes.
So Can you like copy the page for me?
Yeah, don't you have the book?
Yes, but I don't want to take it all the way because I have to go on the bus.
We'll see. Talk to me later. This is my lecture. So yeah, go ahead.
So teachers like that who don't talk at all, they basically did their whole life training to be a teacher and then only taught them about things in the book. So how are they even?
Yes, good question.
They're
I
not
don't
really
know.
a teacher.
I don't know. But anyways, we'll move on. So I lost my place. Hang on one second. Where was I? Okay.
Does your book have all the
1
answers?
Okay, 1 over 4r.
Yeah, he's got the teacher.
All right, so what we're going to do is I'm going to write two fractions. 1 over 4r, where am I? R, 1 over 4r, and r
Wait,
plus 3
what do you
over
mean?
10r squared.
What do you
R
mean and, like
plus
plus?
3 over
It's plus
10
and is plus
r
and not like-
squared. Okay,
Wait, what does and mean?
I'm just writing two fractions right now, right? All we're going to look at is how do you find the lowest common denominator? You can always find a common denominator by multiplying this times this, right? I could do 4 times 10, it would be 40, right? And r times r squared would be r cubed, right? So I could do 40r cubed, but that's not my lowest common denominator, right? It's always a common denominator if I multiply this one times this one. Always a common denominator, but it's not necessarily my lowest. It might be my lowest, but it's not always my lowest, right? So I have to look at, just like I did if it was 1/4 plus, r over 10, I would have to say, oh, well, does 4 go into 10?
In the 20 hours.
No. So if you can't turn 4 into a 10, then go straight to the bigger number and multiply it times 2, right? In other words, if you could do either one. It doesn't really matter. You could just say, okay, 4 times 1 is 4. 4 doesn't go into 10. 4 times 2 is 8. 8 doesn't go into 10. See what I mean? That doesn't really work. But you could. You keep going. 4 times 3 is 12. 10 doesn't go into 12. 4 times 4 is 16. 10 doesn't go into 16. 4 times 5 is 20. 10 goes into 20, right? See what I'm saying? But it's easier if you start with the bigger. I mean, if the littler doesn't go into the bigger, it's easier to start with the bigger, just faster. Because 4 doesn't go into 10, well then 10 times 2 is 20. Does 4 go into 20? Yes. See, in one move I found it. Because I started with the bigger number. It doesn't matter which one you start with. It's faster if you start with the bigger number. If this doesn't go into that, multiply that times 2 and hopefully that'll go into it. If it doesn't, multiply this times 3. And then hopefully that'll go into it. If it doesn't, multiply that times 4, and hopefully this will go into it. If it doesn't, keep going, right? But that'll be a lot faster than multiplying this one, right? You understand that? All right, so 20. Do you guys agree with me that 20 would be my lowest common denominator for the numbers? Okay. So I need this to turn into 20, but now what about the r and the r squared? What would be my lowest common denominator between r and r squared?
20r cubed. No, squared.
20r.
This has 1 r. This has 2 r's, right?
20r.
Oh, yeah.
Right? So I can't turn this into 1 r. I mean r to the 1. But I could turn this into r squared. So really, with variables, you're always going to have
Have the smaller
whichever one is the
maximum.
bigger one, right? That's going to be the one. So it's going to be 20r squared. Did I lose you?
Well,
little
what if the 1 by the 4 was r squared and the 1 by the 10 was r cubed?
That would be r cubed.
Then you'd be r cubed, but how would you get r squared to be r cubed?
You don't.
Multiply times r.
Well, wait. Say it again. What if this was what?
That one's r
cubed?
squared.
This is r squared and this
The
was
other
r
one is r
cubed?
cubed.
Oh, then r cubed would be the one.
Right, but how would you make
Okay, so it's the same issue we have now, right? So the thing is, this is what I recommend, and most people don't do what I recommend. I recommend once you figure out what the lowest common denominator is, write it down and circle it so you know what you're looking at. I know 20 and I know r squared. I'm going to choose the r with the biggest exponent. So 20r squared is my lowest common denominator. So what do I have to multiply 4r by to turn it into 20r squared?
5R.
5r, right? So that means I got to put a 5r up here. What would I have to multiply this by to turn it into 20r squared? 2 here and 2 here. Does that make sense? So suddenly I'm going to have 5r over 20r squared, and I'm going to have 2 times r plus 3 over 20r squared.
R.
Does that make sense? Does it make sense? Does it make sense to you?
Wait, would you
Elizabeth?
distribute
You
the
have your
two?
notes? Are you writing this down?
Yeah.
I don't know my notebooks.
You what?
I don't know what my notebook is and papers.
Well, it doesn't
always
matter.
get
So go get
lost.
paper and get started. Write
Gary,
all
you would
this down.
distribute the 2, right? So it'd be 2r plus 6?
Yes.
Yes, and if I was going to add these, now that I have a common denominator, I would have to
Yeah.
get rid of my fraction, my parentheses, right?
Wait, could you
And add them.
simplify it?
But I'm not going
first?
to do. I'm not going to do this one. I'm not going to
Could
keep
you
going.
simplify it first? Like 5 goes into 20.
Not yet, because see, I just created this so that I could add them, so that I had
Okay.
common denominators. So then I would put 5r plus 2r plus 6, right?
Yeah.
And then 5r plus 2 is 7r plus 6. Not much I can do. That would be as far as I could go, right? So, okay. So that's one. Let's try another one.
Wait, let's solve the total.
Let's try another one. This is the part that's the hardest. And it's not hard. But this is the hardest part, really. It's just getting used to. Thank you. Well, actually, it's all part of example 2. This is all part of example 2, right? So here's another. So that was A. This is now B, okay? So we're going to do B. So we got 5 over x minus 3 squared. And we have over here, we have 3x plus 4 over x squared minus x minus 6. That doesn't look very clear. Okay, so same thing. I have to factor everything. Well, I mean, actually, I
Shouldn't
don't
you put
have.
a plus sign?
I need to figure out what is my greatest, lowest common denominator, right? So this is, let's rewrite this. This is x minus 3 times x minus 3. Do you get me? Yes? This is what?
X minus 3 times x plus 2.
X minus 3 times x plus 3.
Oh, wait, could we do? Oh, wait, no, they're on the bottom.
Okay? So now this is the part that gets confusing for people.
Isn't x plus 2?
I have, I'm going to just circle the common things, okay? I have
Gary.
this. Here, I'm going to do it with a different color for a second.
Gary, isn't x plus 2 in the second equation?
Yeah,
Oh, sorry. Sorry, I was just listening to, I thought you said x plus, I was
And it
just
would be
following.
0, and it would be.
You're right,
x
thank you.
minus-
All right, so I'm going to look at this. That and that are the same. So that's great. They have something in common, right? But this is not over here. You see that? And this is not over here. You see that? Does that make sense? So I have to get this over here. Okay? Because this isn't going to go away. I can't just erase it, right? It's part of the denominator, the x minus 3, right there. And this doesn't have it. It has one of them, but it doesn't have two of them. So this has 2 x minus 3s. This has to have 2 x minus 3s. Does that make sense to you? Has to. So immediately I'm going to, well,
X plus 3.
all right.
You should
put
rewrite
this-
the fraction.
We'll put this, let me use a different marker, go back to my brown again. So that, okay, so we'll just keep writing this, x plus 4. So now, for this one, I am going to have to multiply this by x plus 3. No, excuse me, x minus 3. Over x minus 3. Right? That will now give me an 2 x minus 3's in the denominator. Does that make sense?
But you'll still have.
Now, and an x plus 2. I have, over here, I have 2 x minus 3's in the denominator, just like this. Oh, shoot, but I'm missing the x plus 2.
But
So, I come over here, and, right, I'm going to put my 5 over here. I'm going to multiply this by, what did I say? X plus 2.
2.
X plus 2. X plus 2. So it looks like a nightmare. I agree. Right? Okay? So
Wait, why'd you put the time sign?
So-
Oh, wait, never mind, yeah.
so then what you do is you just, you put them together now. So watch, I'm going to have 5
x plus 2
times x plus 2
plus
over, and I'm going to write them. I am not going to multiply these out. Okay? I'm going to just keep them in factored form. That's key. Do not multiply them out. You are wasting your time if you do that. Keep them. That's why it's so easy. You never have to multiply this stuff, right? In the denominator. So it's just going to be x minus 3 times x minus 3 times x plus 2. Okay? And let's say we're adding these, so I'll put it plus. So then we have this one, I'm going to just do like this. 3x plus 4 parenthesis x minus 3 parenthesis all over. And it's the same thing. It's x minus 3 times x minus 3 times x plus 2. X minus 3 times x minus 3 times
Plus
x
2.
plus 2. Okay? Does that make sense so far? Now, I'm not going to finish this yet. I'm just showing you how to find the lowest common denominator. Okay? Does that make sense? I'm just using this. Now, if I was going to go further, I would have to get rid of my parentheses upstairs now.
So
I would actually be able to combine these, right? I could actually put this all over just one of these denominators, right? And with the plus sign between this thing and this thing. But I would have to multiply 5 times x and 5 times 2. Here I'd have to use FOIL, right? In the numerator. But upstairs you have to multiply them out. Downstairs, don't multiply them out. Keep them factored.
Can't we cross out stuff since they're being multiplied?
This and this?
Yeah, once.
Yeah, but as soon as I do that, I lose
Yeah, but
my
after
common
you add
denominator.
them,
What?
can you add them and then simplify it with
Not necessarily.
Wait,
You have
why
to
can't we
add them
finish
all
it?
first and then see if you actually have two factors that are the same upstairs and
But you
downstairs
could.
without plus signs and minus signs between them. You know what I'm saying?
Jerry,
But for example,
one way. Yes.
just really quickly, hang on.
Sorry.
But this one could do that.
Well, I don't know. I don't really want to go there because I want to do some of the other examples because I don't know if these are set up for that. So I'm just trying to right now focus on
And don't erase it.
finding the.
Don't erase it. Don't erase it. You can erase everything but the bottom.
Wait, we should like.
Yeah, I know. But right now, all I'm trying to do is show you finding the lowest common denominator. Okay, that's all I'm trying to do. Last one. I don't know if I should go with the last one. Yeah, last one. We got to do the last one. So this is 2c. Because the last one, okay, it is 3 over where am I? X minus 2 and x plus 8 over 2x plus 7. All right? So if I was going to, I'll just say, instead of and, I'll just put a plus. So if I was going to add these, this is a blob, right?
Bob.
This is a blob called x minus 2. This is a blob called 2x plus 7. There is no similarity in these two. They are totally different.
They
Agree with
have
me?
x's.
There is no way I can turn this into this. No way. Absolutely no way. Therefore, my lowest common denominator is simply multiplying this times this, right? There's no other way to do it. I've just got to multiply them together. So that means this fraction needs x minus 2, right? And it says this fraction needs 2x plus 7, 2x plus 7, 2x plus 7. And then I would multiply, these would be like this, right? And this would be like this. And then I would leave this down now in the denominator and multiply these out in the numerator. Use FOIL for this in the numerator. Okay? So that's just, but I'm not worrying about the numerator right now.
But then on
I
the
was
bottom,
just showing you the denominator.
then like it would be 3 over x minus 2 times 2x plus 7.
It would be 6x plus 21
Oh,
over
yep,
x
never mind.
minus 2
And
times
the other one
2x
would be
plus 7.
x squared minus
Yeah.
Right.
16.
Right, plus, 6x minus 16. Okay, so now let's start doing real problems. Okay? And you'll see how they work.
Wait,
We're
what?
doing okay. So we're not doing okay. I just realized.
It's
Number,
9 o'clock.
yeah, so don't tell anybody. Okay? All right, don't tell Nate.
Nay.
Okay, So here's our first one. This is example 3. Example 3. 9 over. So Nate, if there's any way I can have more time, I'm totally in favor of that.
Is he even in here?
Probably the East Coaster folks are.
I'm hoping that they'll start late. All right. Okay. All right. So now here we go. I look. Okay. Does 8 go into 12? No. They're not here.
Yeah, so 4 goes into both of them.
Does 8 go into 12? No. Therefore, I'm going to start with the 12. 12 times 2 is
24.
24. Does 8 go into 24?
Yes.
Okay, I know that 24 is going to be one of my lowest common denominators. Well, now I have an x squared here, and I have an x cubed here.
X, 24x.
So I want.
Wait, no.
I know I can multiply this by an x to turn this in, to turn it into an x cubed, right? So I want x cubed to be my lowest common denominator. Does that make sense? Be really easy. So 24x cubed. That is my lowest common denominator. So now I come back here and I say, what do I have to multiply 8 by to get 24? 3, right? And then x squared to get x cubed, x. 3x times 8x squared is going to be 24x cubed. It's really helpful having this written here. If you don't have this, you're going to do it hard. It's going to be harder for you. It's going to take you longer, guaranteed. If you have that to look at, because you spent all that time figuring it out. If you don't write it down, then you're going to forget. And you're going to have to figure it out 4 times while you're doing this, right? So write it down and circle it. So that's going to give me 24x cubed, all right? So I got to put a 3x here too. This, all I need to do is multiply this times 2, right? All right? So now I'm going to multiply it out. 9 times 3x is 27x over 24x cubed plus 10. 5 times 2 is 10 over 24x cubed. Okay, now that I have common denominators, I can add the numerators and put them all over that same common denominator. So my denominator is 24x cubed. My numerator is 27x plus 10. 27x plus 10.
That's the answer?
And now I have to ask myself, can I factor? Now that I've added everything together in the numerator, I look at the numerator and I ask myself, can I factor that? Is there anything that goes into 27 and 10? No, there isn't. So now I'm done. There's nothing else I can do.
But say
But
that
the
was
goal
like
is,
20.
I mean, it would be awesome if I could factor, if it was 27x squared plus 10x, I could factor out an x and then I could take one of the x's away from here, right?
I'm telling you.
I mean, but that's not the
And
case.
then you
in
would
this one.
cross them off, right?
Cross what?
The x's once you took them out.
If that
Yeah,
were the
if it
case,
was.
then you could cross that. All right, so that's that one. That was example 3. I should have asked you, is that okay to
No,
raise?
simply.
Example 4.
Oh, what?
Wait, what?
Example 4. Yeah, those were the easy, these are the easy ones. Try this. We'll try 10 over 3x minus 7x over x plus 2.
Greatest common wage.
Okay?
Greatest common.
So lowest common denominator. This is 3x.
That's x plus
This is a blob.
You must multiply them together.
They are not the same at all.
So
I
3x times
cannot
x plus 2
turn
is the
either of
denominator.
these into the other. There's no way. I can't multiply this times 3.
Oh, we're subtracting.
I would
Yes,
get
parentheses.
3x. I would get 3x plus 6, not 3x. Right? I can't add 2 to this. You have to multiply it times something, right?
Yeah.
So the thing is, my common denominator is going to be this times this. That's it.
Would you multiply
So
the top by
in this
2?
case, I wouldn't write it out. I would just do this right away. I got to have a 3x over here, right?
So it would be
top and
10
bottom.
times x plus 2 over
And I
3x
have to
times x
have
plus 2.
X plus 2 over x plus 2 over here, right? You with me? So now I will have the same common denominator because it'll be the same. But now I have to multiply the 10 times the x and the 10 times the 2 using distributive property. And I have to multiply this times this. So let's do it right now. We have 10x plus 20 all over x
3x.
plus 2. Yeah, well, it'd probably be easier to write it that way. 3x parenthesis x plus 2, right? And then I have minus 21x squared, right? All over 3x times x plus 2. Now I have common denominators, right? And I can combine my numerators now. So let's do it right now. So we've got, well, keep going this way. So we have we have negative 21x squared. I'm going to put them in the right order because you want to put your highest exponent x first, right? So I've got this minus means it's negative 21x squared plus 10x plus 20 all over 3x times x plus 2. Now, there's a chance I could factor this, but it looks like a pretty slim chance, right? If I were going to try, I'd have to factor out a negative 1, right?
But Gary,
So that would be positive 21x
so
squared. minus
so
50.
whatever is on the second fraction, if it's subtraction, will be negative.
Correct.
Are there going to be any of these?
And you'll see this on the next one. But that's probably as far as I'm going to be able to go. Because 3, I can't take any greatest common factor out of any of these. There's nothing I can do. I might be able to factor that using Gary's terrific trick, but it just looks like a nightmare.
They're coming next
Next Wednesday?
Oh.
month. Do you want more time?
Well, just give me, I want the full time. So don't ring the bell. Can I erase? So we're done. I can't go any further. I don't think. Let me just see if they did on the book. Where am I? Which one did I do?
4 something.
Oh, wait. Hang on. Wait a minute. Which one did I do? Oh, this one. Oh, yeah. That's all they got. They got the same thing. Okay? So, so that was example 4. We only have one more example. Okay? Is it starting to make sense? A little bit? Now the goal, though,
Just a
is
wee bit.
ideally the ones that are the most fun to do are when you multiply the numerator stuff together and then add them together and you get it. Then you add like terms and you get something new. Then ideally you can factor that numerator, and then you have things upstairs and downstairs, just like you did when you had simplifying rational expressions. It's fun. It's fun. Okay,
Yay,
please. I
yay.
hope this one works that way. Yeah, this one will work that way. Okay, let's try this. The last one, example 5. So, Nate is not here. Don't let him ring the bell, okay?
Ding,
If-
ding.
Gary, do you want 5 more minutes?
Well, I don't know. Let's just try this. Okay, x squared. I think I am going to need 5 more minutes. Yeah, I am. 3x minus 10. Where am I? Okay. Minus x minus 1
Do it, Fiona!
over x squared plus 2x minus 8. Now, I'm just going to double check I wrote this right because this is not a good time to have
Whatever.
my... Okay. So,
Get you back for that one.
so now I have 2 rational expressions that with quadratic trinomials in the denominators. And just like all the other days, you have to factor first, right? There is no way, absolutely no way, to know what my lowest common denominator is. I need a little more time.
5 and negative 2.
I can't know what my lowest common denominator is until I factor these. That's the only way, right? So I'm going to factor this. So I've got x plus 4 on the top. There's nothing more I can do with that. But factors of negative 10 that add to 3.
Positive
5 and
five,
negative
negative
2.
Positive 5, x plus 5 times x minus 2. All right? Negative 10, yes. 5x minus 2x is 3x, yes. Okay, and then it says minus. We're going to put an x minus 1 here. And then we have
X plus 4x minus.
x plus
4x minus 2.
4x minus 2. Okay,
So wait, can you cross it?
negative 8, that's right. And
Wait,
then
here, can you cross
4x
it?
minus 2x is 2x. All right, what?
Cross out x.
I can't
No.
cross anything out.
No, because this is
Not being
not
multiplied together.
multiplication.
What I'm doing now,
No.
what I'm doing now is I'm seeing if I have common denominators, right? So I have an x plus 5 and an x minus 2. So the only thing I have in common is the x minus 2, right? that I have in common, right? But what I'm missing is this has to be on this side. I have to get an x plus 5 over here, and I have to get an x plus 4 over
So
here.
would you multiply that by x plus 4 and the
Makes
other one by
sense?
x plus 5?
So yes, so this, all I have to do to get this over here is just multiply this fraction by x plus 4. X plus 4. And then with this one, I have to multiply it by what I'm missing, x plus 5. Right? X plus 5, x plus 5. Okay? Is everybody with me? Does that make sense? All right. So now I have my common denominator, right? Boom. And upstairs I have these binomials multiplied times each other. It's going to have to use FOIL, right? Does that make sense? It's parentheses x plus 4 times parentheses x plus 4. I've got a FOIL. And then FOIL x minus 1 times x plus 5. So that's what I'm going to do right now. X plus 4 times x plus 4 is x squared plus 8x plus 16. Am I right? You have to multiply the numerators out. You do not multiply the denominators out. Okay? All right? So now I have x plus 4 in the denominator times x plus 5 times x minus 2. And then I have a minus. You see what I mean when I said these are the most difficult of all of them? I mean, it's just,
Gary,
there's a
you
lot of
close that
steps.
parentheses.
They're
It's
not.
not necessarily
It's just-
Gary, you
hard.
close that parentheses on the x minus 2.
Thank you.
They're not hard.
They're not
just
hard,
take a
they're
long
just a
time.
lot of steps. So now x minus 1 times x plus 5. So we've got x squared. So 5x minus 1x is 4x, plus 4x minus 5. Did I do that right?
Well, plus.
And then I've got the same thing, x plus 4 times x plus 5 times x minus 2. Okay.
I'm so confused. Wait, Gary, how did you multiply the 5, the x plus 5 and the x?
So FOIL. First, x times x is x squared.
Outside.
Outside, 5x. Inside, negative 1x. 5x minus 1x is 4x.
Wait, so, and then wouldn't the...
And then negative 5 times 5 is negative
So
5.
just
If
FOIL
it's
the
that,
I just
wouldn't it
FOIL.
be 4x minus 4x
Okay,
plus 11
so wait.
over that?
So now we can combine them over one denominator, right? You agree with me? Because we have common denominators. So that's what I'm going to do now. But you got to watch something because this thing is like critical. This thing right here is critical. That says minus. That means it's minus x squared minus 4x plus 5. Do you see that?
And then don't the x squareds cancel each other out, and then 8x
I can tell.
minus-
I know some people didn't hear me. That's critical. Everybody look at this. That minus sign says I'm minusing each of these things. I'm minusing an x squared. I'm minusing a positive 4, which means minus 4. I'm minusing a minus 5, which means plus 5. Right? You with me? Right? So that minus sign affects everything. It's like
4x
you have to
plus
multiply minus times everything in here. Does that make sense? Okay. So here we go. So we're going to combine these together. Okay, I'll just do it. I'll do it in 2 steps. 2x squared. I'm going to cross this out. I just did that. I've got minus x squared. Minus x squared. Oh, look at that. I got that. And I've got plus 8x minus 4x. You see what I'm doing? I'm putting them in together so it's really easy to find them and to simplify, right? 8x minus 4x, and then plus 16 minus a minus 5, meaning plus 5.
All over
All over
x
my
plus
same thing, x plus 4 times x plus 5 times x minus 2. Now I simplify. Now this is the fun part, right? This is where, oh yes, I get to get rid of my x squareds because they cross out, right? X squared minus x squared is nothing. Okay, I got rid of those. Now, 8x minus 4x, that gives me 4x. So this gives me 4x
Plus 21.
plus 21
over x plus 4 plus x
over
plus 5.
x plus 4 times x plus 5
But that is the worst.
times x minus 2.
Carrie, that is awful.
Isn't that fun?
Yes, but it takes a
Very
long time.
Gary, can you only
So now I have to
do
look
the
at
odd
this, and is
problems?
there, I look at this, the last thing I do is I look at my numerator, and I ask myself, can I factor that? No, there's nothing I can do. So there's nothing upside. But if, let's say it was 4x minus 8. I could factor 4x minus 2. I could cross out my x minus 2's, right?
Wait,
So
would you
up top
simplify
and
the
bottom.
things on the bottom and like multiply them together?
No,
the
always
denominator?
keep them,
Just always leave it?
keep them like that. You don't need to multiply them out.
It's like those
So
aren't
that's
that
it.
hard. They just
That's
take
it.
a long time.
They just take a long time. So that's going to be the homework tonight.
How many?
I'm going to turn this